Example 14.2. A study was conducted to determine if there is a significant relationship between the frequency of times meat is served as a main meal per month for individuals living in the eastern, central, and western United States. Do these sample results indicate that there is a significant relationship between the frequency of meat served as a main meal per month and geographic location at alpha equal 5%? So again, when a problem like this is presented, you'll also be given a table of data values. So you'll see that you'll have sample data in the form of a matrix, and you'll know that you have to do the chi-square test. The hypotheses, HO is going to be the population classifications, frequency of meat served as a main meal per month, and geographic location are independent. So our null hypothesis is always going to state that the two classifications are independent or not related. And then our alternative hypothesis, the population classifications, frequency of meat served as a main meal per month, and geographic location are dependent. So that's the way our alternative hypothesis will always be stated, that the two classifications are dependent. So if we look at our sample data, you can use the sample table. You can use the titles for the rows and columns. Here the column header is frequency of meat served as a main meal per month, and the row header is called living area. You can use those to easily construct your null and alternative hypotheses. So the data is in let's see, we have 3 rows, Eastern, Central, and Western, and we're going to disregard the column totals when we use our calculator. And we have 3 columns, less than 11, 11 to 20, and more than 20, and then disregard the row totals column. When asked for the distribution, what distribution are you using? You're going to state the chi-square distribution. The decision rule. So if you consider what the chi-square distribution looks like, the alpha that we were provided in this problem is 5%, so the shaded area in the right tail is 5%. We are going to reject the null hypothesis if we can get a p-value that is smaller than alpha. So reject HO at alpha equal 5% if the p-value of the sample statistic is less than or equal to 0.05. So our decision rule has remained constant through every hypothesis test that we've done in this class. Every time we need to construct a decision rule, we always want the p-value to be smaller than or equal to alpha. And alpha will either be 1% or 5%. The sample data. So we have our table, and we have to enter it into the calculator. So if we go to the calculator, and I'm going to open up that sample data again. Okay, if we open up the calculator, I'm going to keep putting data into the matrix A. So second matrix, go over to the edit menu, hit enter, and we have 3 rows, so we're going to change the 2 to a 3, and 3 columns, so we could leave that as is. And I'm going to use my arrow down to go into the table to start writing. 46, 36, 20, 40, okay, 40, 26, 16, 38, 38. And now we run the chi-square test. So stat, tests, letter C, Okay, be careful. There are two chi-square looking tests. One is called chi-square test, that's the one we're using. And then there's one called chi-square goodness of fit tests. The textbook can tell you more about the goodness of fit test. We're not going to do it in this class. So we're going to hit enter on C, chi-square test. Observed, we can leave it A. Expected, we can leave it B. And then we go down to calculate. So what's going on when we run the calculate function, or when we hit calculate, is basically the calculator is generating an expected matrix, and it's going to populate matrix B with all those expected values, and then it's going to use those expected values to come up with a value for the chi-square test statistic. And then it's going to find the area from the chi-square test statistic to positive infinity to find the p-value. So for our purposes, we don't really need to worry too much about the expected matrix B. We really care about the chi-square test statistic and its p-value. So we hit enter and we get chi-square equals 20.89 and p equals 3.322. That should make no sense to you because p-values are probabilities and they're supposed to be between 0 and 1. So you look a little bit further and you see that you have e-4, which is telling you that this is given to you in scientific notation. So you have to move that decimal point 4 places to the left, and you're going to write it in standard form rounded to 4 places. So let's go to the PowerPoint. Okay. The symbol of the sample statistic, when asked what the symbol is chi-square. The value of the chi-square test statistic is 20.89. The p-value, if you consider the fact that this is scientific notation, it's 3.322 and more times 10 to the negative 4. So you're going to take this decimal point and move it 1, 2, 3, 4 places to the left and pad those places with zeros, and that gives you the value of 0.0003. So our p-value, 0.0003. Very small, very, very small area. So it's a very small p-value. Our conclusion is, since the p-value is smaller than alpha, we reject the null hypothesis at alpha equal 5%. Okay, so if we take a look at alpha equal 5%, and then we consider the p-value that we got is a lot smaller than 5%. My picture doesn't show it as a lot smaller, but it is smaller. So just recognize that when you have a p-value that fits inside alpha, it indicates that the chi-square that you got is far enough away from 0 so that you can reject the null hypothesis. Okay, you want that value to be highly significant, and small p-values are more significant than large p-values. So you're going to answer the final question, do these sample results indicate that there is a significant relationship between the frequency of meat served as a main meal per month and geographic location? So when you reject the null hypothesis, you prove dependence. When you fail to reject the null hypothesis, you've shown that they are independent. So we've rejected the null hypothesis. So we have shown that we do have a significant relationship. Yes, there is a statistically significant relationship between frequency of meat served as a main meal per month and geographic location. And that means that the two classifications are dependent. That concludes this lecture on chi-square. Chi-square is usually one of the hypothesis tests that students find the easiest. So it's nice to end the semester on that note. If you have any questions, you can email me, post them in the discussion forum. You have a web work question